we're going to be talking about now we're talking about the volume of cones. And just like in every other video that I've talked about as far as volume goes, volume of cylinders, rectangular prisms, triangular prisms, whatever, pyramids, I give a basic definition. And I'm sorry, I do apologize. My definition keeps changing a little bit the more I start thinking about things. And I'm, you know, from one video to the next, I start remembering, you know, I probably should have said it like that, or maybe I could have said that better. And so I'm refining it as I go. And I guess I should have like maybe just looked it up in a dictionary, but I kind of find those dictionary definitions to be a little dry, and I like to have my own understanding for a definition of what volume is, for example, or what area is. And I suggest maybe you guys do the same thing. But anyway, so now the definition is that volume refers to the amount of space inside a three-dimensional object. And I don't think I said that before. I think I just said an object. And again, like, you know, my water bottle, I always bring my water bottle. And it's something that has, it's like a container, but I also said that it could be a solid, okay? So that would be, that volume is the amount of space that an object takes up. How much space does that solid use up? So that's what we're talking about. Anyway, okay, moving on. So the formula for the volume of a cone has components from previous formulas that we've already used. And this is the formula for this is the formula for a cone, the volume of a cone. And you can see that we have this pi r squared. What's that for? What's that? What's pi r squared for? Your clue is the squared. Well, that's the area of a circle. Area, not volume, just the area, the flat surface of a circle. How much space is that flat two-dimensional circle? And then what's this formula? Pi r squared times h, or times height. That's the volume now, because we had the circle, which is area, multiplied to a third dimension. We're talking about volume at that point. And that pi r squared times h is the volume of a cylinder. And just like the pyramid, that was a three-dimensional box that got pinched into a corner, or into a point, right? It had it's like a cube, and those four sides come into a point, making a pyramid. This is a cylinder. Well, use my water bottle again, right? This is a cylinder that gets pinched into a point. And because they're both three-dimensional figures, the box and the cylinder, the three-dimensional figures, to get them into that point, we divide by 3 because it's a three-dimensional figure. Okay? All right. But again, so you can see how it's area of a circle, volume of a cylinder, then divided by 3, volume of a cone. So the formula isn't like getting radically different. We're just adding one more thing to it, okay? But it is important to understand what pi r squared is. What is that? What's it for? It is important to understand what pi r squared times h is. What's that for? And it is important to understand what the whole formula is for. Obviously, the volume of a cone. And I also said that algebra foo will be needed, okay? Your algebra foo, your kung fu, your algebra foo must be strong, okay? Because especially with circles, well, because it's circles and we're using pi, it's going to have a crazy long decimal. So for the most part, it's a crazy long decimal. And we'll be rounding around, we'll be estimating, approximating our answers. And because it's a square, sometimes we might have to do the square root. So that's what I mean by our algebra foo. We have to have good algebra. All right, so let's get started. Let's take a look at the first one. Okay, here's our first example. So just to recap, remember that when we're using pi, we're going to use a calculator for sure, right? And so get your calculator out, get it ready. All right, now, so I have a cone here. And to find, well, I have the formula right over here too. So the formula for to get the volume of a cone is pi r squared times h divided by 3. Where pi is that Greek letter that is going to be equal to 3.14. And that's what we're going to use when I write it on the board. Of course, like I said, we're going to use a calculator to represent pi, like I have when we deal with circles or cylinders, same thing. And r squared we'll put in this first pair of parentheses, and then we'll put the height in the second pair of parentheses, and then all this has to be divided by 3. The 3 is just a constant, okay? Now, radius squared. We have to know what radius is. What is radius? I didn't give any clues this time like I did in the area of a circle. Radius is the distance from the center of a circle to an outside edge. In this case, I could probably just go that way. It's that distance, all right? And it is contrastive. I'm not sure if that's the right word. It compares very well with diameter. Remember that diameter is the distance across the circle from one side to the other, passing through the center, or basically the longest length from one side to the other of that circle. And so here in this problem, they give us diameter, 12 centimeters. But we don't want 12, right? We don't want diameter. The formula is asking for radius. So the radius is half of the diameter, okay? All right, so that's what we're going to use. We're going to use 6. So the radius here, I'm just going to get rid of part of that circle there, is 6 centimeters, okay? It's half of the diameter. And that's probably maybe the hardest part to identify in one of these things is what's the radius, what's the diameter, what did they give me? Make sure that information is organized and clear in our head, right? Okay, so 6 squared. All right, and the height, or the h times h is 5. That's the height, right? So 5. And that's basically it. I mean, obviously we have to solve it, but as far as setting up the problem, it's not too crazy. It's just a basic formula that you just plug in the information from the problem into the thing. Radius, make sure you understand what that is. Okay, so now that we have all these operations, let's count how many operations we have. We have pi times radius squared, so we have a multiplication, one multiplication. After that, then we have another multiplication times 5. We have an exponent, that's 3 steps. And we have all that divided by 3. So we have 4 operations that we have to do. There's 4 things that we have to do. 2 multiplications, an exponent, and a division. Now the question for you is, which one of those 4 gets done first? Well, in my video of order of operations, I explained that exponents get done first above multiplication and division. Okay, so we have to do multiplication and division after we do exponents. So I'm going to solve the 6 squared thing, okay? So I'm just going to go ahead and bring down my pi. 6 squared is 6 times 6, or 6 multiplied by itself, or to itself, 2 times. Okay, that's what that little 2 means. You're never going to multiply 6 times 2. That's not what's going on when we're working with exponents. So 6 times 6 is 36, or 6 multiplied to itself twice is 36. And times 5 divided by 3. Okay. And honestly, I don't know what 36 times 5 is off the top of my head. If I did, I might simplify that one more step just in my head. I think at this point, we're just going to have to go into the calculator, okay? And we're just going to make an approximation. I haven't done this problem yet, so we'll just do it together. All right, so here's the calculator. Our pi button on this calculator is right here, so pi. And it just gives me the little Greek letter pi, right? Times 36 and then times 5. So, oh, I guess I should have said after the exponent, we have multiplication and division. Typically, the multiplication will come first, okay? All right, for the most part. And in this case, you know, when we're talking about the fraction, I want to know what this whole numerator is first. Take that number and then divide by 3. So the division will be last, okay? All right, back to what we're doing here. We have pi. Trying to find a good angle there where you can maybe see. Pi times 36 times 5. Okay, and I'm sorry. In this calculator, you can just kind of put them all together. Pi times 36 times 5, enter, and it gives us 565.483 or 0.4866 and blah blah 776. Now, because that's my whole numerator, and I am going to approximate, but I want to approximate mostly the final answer. If I need to, I have to divide still, so I think I can just keep that whole number there. Watch this. On this calculator, and pretty much all of them, you just hit divide. Boom. And it throws in that little answer, or ANS, right? Answer. And basically it's saying it's taking that whole long decimal. And if I use more decimals, the answer is going to be more precise. And that's why I want to do it that way. So answer divided by 3. And that gives us 188.49, basically 188.5. I'll just say 0.5. Okay, so you see how I did that, right? So the volume is 188. Rounding up the 0.49 to 5. I'll just say approximate. Why not? That's what those little squigglies mean. Centimeters cubed. Okay? So, again, order of operations is important. We don't want to forget the order of operations. Exponent first. Figure out what that numerator is first. This whole thing on the top over the fraction bar. And then, so yeah, but out of those steps on the numerator, we have to do the exponent first. And then it's just all straight up multiplication. Get that answer, you can hit enter, and then you get this big number, what was it, 300 and something, I forget. And then I just hit the button divide, boom, 3, and I get a really precise answer because I used that whole long decimal after that multiplication, okay? So that's what the volume of that cylinder is. It is 188.5. So this, again, just real quick, this is just a basic, straightforward. They give us information, enough information, and ask us for volume. That's how you do it. You just go straight forward. Let's look at some where they start taking some of that information away and presenting it in different ways. All right? Okay, this is another problem that we've seen problems very similar to this one already. If you've already seen other volume-related videos that I've done, I do one that's pretty much like this every single time. There's one in the cylinder that's pretty much identical. Except that this formula is a little bit more than just the volume of a cylinder. This has one more step more divided by 3. And we got to take that into consideration, right? So here's the problem. I have a cone that's missing its height. That's obviously what the question is. What's the height of this cone? They give us a measurement here. What measurement would that be? 4 inches represents what? It represents the diameter. Remember, if it's going from one side of the circle to the other, it's diameter, okay? And obviously the circle base, right? And it gives us V volume is equal to 33.5 inches cubed. Now, even if they didn't give us the letter V or tell us that it's, volume, if they say inches cubed, without a doubt, it is volume. Okay, remember that. Units cubed is always an answer about volume. Units squared is always an answer about area, okay? So again, they didn't have to be that explicit, but I still helped you guys out. I'm such a nice guy. I give you guys the V for volume. Okay, and then we have our formula, right? So when we do these kinds of problems and they're missing a dimension, right? Like in this case, we're missing the height. What do we do first? We got to go back to the formula. In other words, we have to ask ourselves, how did they get 33.5? How did they get that? What did they do to get 33.5 for the volume for that cone? Well, they use the formula like we have to use, like anybody else. So they did pi r squared times height divided by 3, and they gave them 33.5. Okay? And that's it. I'm not going to put the inches cubed. I'm setting up the equation, right? All right, and it's an equation because I have equal sign and information on both sides. And on top of that, there's only going to be one thing missing. And that's going to be height, okay? So, pi, we know that pi is always, well, I always use 3.14. When I'm writing it on the board, I use the button on the calculator when I'm, solving it. I'm going to put a pair of parentheses here for the radius, and what the heck? Put a pair of parentheses here for the h. Okay, for the height. But what's the radius? The radius is half the diameter. If they give you the diameter, it's half the diameter. Okay, so it's going to be the distance from the center of the circle, the circular base, to an edge. In this case, it's going to be half the diameter. It's 2. All right. So it's 2 squared. There we go. And all that needs to get divided by 3. And then that's going to be equal to the same thing, 33.5. And again, I say this a lot. It's good to be organized. Write everything, okay? Write everything, especially if you're just learning this for like the first time or you're barely getting into it. If you're an expert like me, you can be all messy. No, just kidding. No. Even that, I'm not messy. I try not to be messy when I'm solving my problems. So now this is definitely a solvable equation because there's only one letter missing, or one variable that's missing. That means that all this can be simplified and then moved over to the other side with, to group the like terms. All the numbers can go on one side, leaving the h by itself on one side. And when h is isolated on one side of the equal sign, it tells you what it is. H is equal to this, or the height is exactly this, okay? All right, so what do we do first? Well, I need to work on this side. I'm trying to get h by itself. So I can simplify some of these things. Out of all the simplification that I should do first, I should do the exponent first, okay? So 2 squared is 4, it's 2 times 2. Remember, it's not 2 times this little 2, it's this big 2 multiplied to itself 2 times, okay? So it's gonna be 4. So let's just rewrite everything. Here we have pi times 4 times h divided by 3, okay, is equal to 33.5. All right. Now what do I do? Well, there's still some simplifying I can do. I can multiply the pi times the 4, and I'll go ahead and do that and use my calculator to do that. All right. So pi is that little button that I got on this calculator. Find the one on yours. Times 4. And that gives us 12.566, but 37. I'm just going to go 12.56, and we'll call that good, okay? And you guys can do the same. 12.56. And now I'm just going to get rid of the parentheses, now that all these numbers have been simplified. So it's 12.56h divided by 3 is going to be equal to 33.5. Now this is very similar to when we were working with the pyramids, right? With the pyramids. Feels like I'm Egyptian or something, right? When we were doing the pyramid has something very similar to the cone in the fact that they both have a point. And because they have that point, we have to divide something by 3. And so here we are with this equation where we have a division by 3. And I said this is the point when we want to, in the pyramids I was talking about that this is the point where we want to get rid of the fraction. To get rid of the fraction, the only thing I can really change is that denominator, okay, in the fraction. So how do I get rid of this divided by 3? Well, I have to do the opposite operation. Algebra is based on opposites. That's how you get things to move around, from one side of the equal sign to the other. You do opposite. So in this case, I'm trying to get rid of the divided by 3 because that's the only thing I can really change, okay, that I want to change. To do that, I do the opposite, multiply by 3. I'm going to use my point, right, and I'm going to represent 3 as a fraction. That point right there is multiplication, okay? I'm going to represent 3 as a fraction, and that means putting it over 1. 3 over 1 is 3. It basically says 3 divided by 1. Well, that's still 3. So that says 3. And if you don't know any of that, go back to multiplying fractions, okay? I do this kind of thing in the algebra videos too, okay? So go back and refresh your memory. Now I can cross cancel, so the 3 and the 3 mean, cross canceling means that those two numbers, a numerator and a denominator from different fractions, can be reduced to a smaller number, basically dividing a common factor. So I'm going to divide both of these 3's by 3. 3 divided by 3 gives me 1. 3 divided by 3 gives me 1. Now in multiplication of fractions, because that's what I have here, I have a fraction times a fraction, what this point means multiplication. It's just 1 times 12 and 1 times 1, and the numerators stay in the numerators and the denominators stay in the denominators. No cross multiplying, none of that. So 1 times 12.56h is 12.56h. Okay, actually, let me write that just a little bit closer. I like to have it looking like a multiplication. Okay. And if I was to put the fraction bar and go 1 times 1, that 1 times 1 is 1. But the same way that 3 divided by 1 is 3, same thing here, 12.56h divided by 1 is 12.56h. Okay, so I don't need to put that 1. Basically, that's how the fraction gets eliminated. However, What I do to one side of the equal sign, I have to do to the other so I can maintain equilibrium. That's what the equal sign means, right? Now, what I did on this side, I did it in red. I multiplied times 3. Over here, I'm going to multiply times 3. Over here, I don't have to put it in a fraction form because there's no other fraction in that multiplication. I had to put it in a fraction over here because I had a fraction in that multiplication. So if there's a fraction in a multiplication, everything has to be in fraction form. If there is no fraction, you don't need to put nothing in fraction form, okay? So 33.5 times 3. Go ahead and break out your calculators and give it a go. I'll just do it here with you guys. Let's see if I can get some angle where you guys can see the screen. Oh my gosh. Okay, so 33.5 times 3. And I think you guys can see that. Maybe this way. Yeah, it looks pretty good. 33.5 times 3 is equal to 100.5. All right, so we have 1 is equal to, yeah, so this multiplication is equal to 100.5. Okay? Kind of sounds like a radio station or something. 100.5, cool jazz. Anyway, so the last step here is to get h by itself. That's always been the goal, but now we only have one number stuck to the h. Before we had all this other stuff stuck with the h. So what we do here is we have to divide, because remember that the 12.56 is multiplied to the h. To separate them, or to break them apart, to undo that multiplication, I have to do the opposite operation, always. And that's going to be divide. And I'm going to divide by the number that I'm trying to get rid of. I'm trying to get rid of the 12.56 so that h stays by itself. So I'm going to divide by that. And 12.56 divided by 12.56 cancels out, leaving the h isolated, right? Okay. And I was writing kind of small and kind of crowded because you can see I'm coming down to the bottom of the screen here, and I'm like, oh, I don't want to run out of space. Anyway, but what I do to one side, got to do to the other side to maintain equilibrium, to maintain equal. And I divided by 12.56, so that's what I'm going to do over here. Divide by 12.56. All right, and we'll break out the calculator. So 100.5 divided by 12.5, oops. Yeah, here we go. You guys can see that one, right? 100.5 divided by 12.56, and that gives us 8.00. So the height is 8. Yay, we got to the answer. 8, what do we have, inches? Okay, so this is going to be 8 inches. All right, there it is. So I can't emphasize enough your algebra foo. Your algebra foo has to be strong, right? It has to be really good, really solid all the way through. Step by step, write everything out over and over and over. Each time you do one thing, one operation you do, and you finish that operation, write everything that you did. Okay? Like here, we had the squared, the 2 squared. We rewrote everything, or I did, except for the thing that I did. I did the 2 squared. There it is. The next step was to multiply the 3.14 times 4. I did that and wrote everything else the way it was. And then I changed colors because I think this is where people get really confused when they have to get rid of a fraction. And go to back, check out those videos in solving algebraic equations with fractions. It's one of those ones. It's in there, I promise. Might not be labeled like that, but it's in there. And this is where we have to cross cancel the 3's, basically leaving us with 12.56, and then we multiplied this side by 3, we multiplied the other side by 3, got 100.5. Last step was to separate the 12.56 from the h. We did that with division because they were multiplied, so opposite operation is divide. Did the same thing to both sides, and we got h alone equal to 8. Whew, man, that is some work, right? So it's not, I'm not saying it's easy, but really with a lot of practice, you'd be surprised how quick you can get to these answers. Okay, so you got to be good with the multiplication tables, you got to be good with the algebra, and you have to understand, recognize what 4 is in this case. You have to understand the difference between radius and diameter, okay? Let's take a look at a different kind of problem using cones. Okay, guys, this is another problem. We're talking about volume of cones. This one's actually a little bit easier than the last one we did. And we have one more after this, just to let you guys know. Sometimes they write down the problem. Sometimes they can actually describe this entire problem in a paragraph form. So I'm not going to do that, but practice your reading comprehension, okay, when it comes to these kinds of math problems. But here we go. This one is basically saying to find the volume. They're asking us what the volume is of this cone. And we know that the formula of a cone, right, is pi r squared times height divided by 3, right? There we go. Divided by 3. Pi r squared times height divided by 3. Well, can I do that? Well, pi, we always have pi, right? Pi is 3.14. Do we have radius? Right? How about before I even continue, how about you guys try, I already kind of started the brainstorming process. Why don't you guys see if you can figure out what the volume is? Okay? And your clue is that it's actually a little bit easier than the last one that we did. So go ahead and give it a go. All right, what did you guys get? It should be a pretty big number. Okay, kind of a big number. Well, let's see here. They didn't give me radius, so how am I going to find the volume? Well, they did give me something else. They gave me this little piece of information, 153.9 meters squared. What does that mean? What does that represent? And how do I know, right? What's telling me, other than it being a number, what else is it telling me? It's telling me that it's area. And how do I know that, right? I know that because they're giving me meters squared, units squared. Now, for example, if it was units cubed, that would be volume. I've said this before. So pay attention to those units. They're telling us a lot of things right there, okay? Meter squared, area, meter cubed, or unit cubed, volume. So this is area, because it's the area of something, because it tells me that it's meters squared. So what's it the area of? It's the area of the circle, okay? The area of the circle is 153.9 meters squared. So we have to ask ourselves, what part of the formula is talking about the area of a circle? And this is why at the beginning I said that these kinds of formulas, and I talked about it also in pyramids, but these kinds of formula and cylinders, these kinds of formulas, they build on each other. And we have to start recognizing what this is, what that is, what the whole thing is, okay? So, area of a circle is located in this part of our formula for the volume of a cone. Pi r squared is the area of a circle. That's how you find the area of a circle, is pi r squared. So they did that already. So they kind of helped us out. And this is what I was trying to tell you, that it's a little bit easier than the last one we did. So I'm going to go ahead and substitute 153.9 for pi r squared. Okay, times height. Use parentheses. My height is 12, right? Right? And all that divided by 3. At this point, it's pretty much just a calculator thing, okay? So it's not too hard to plug into a calculator, and we'll get the volume. All right, so trusty old calculator. Actually, it's not that old. Anyway, so I'm going to multiply 153.9 times 12. 153.9 times 12. Okay, let's go ahead and figure out what that numerator looks like. The numerator is 1,846.8. Now I'm just gonna hit divided by, and what that does is it puts answer ANS, and that just means it's the 1800, and that's right here in the form of ANS. Okay, so it just means my previous answer, this divided by 3, and that's equal to 615.6. Okay, so, oops, let's just go over here, get my marker. What was it again? 615.6. This time I have to put units, or meters in this case, cubed, to show that it's volume, okay? So again, in this one, they gave us a big help. They gave us the area of the circle. Our job is to understand that it's area, because they didn't say area. Well, they didn't use the word area. They didn't even use the letter A, like to give us a clue, right? Sometimes they don't do that. And the idea here is to understand the language of the unit squared versus just the unit, like if it was just meters, or if it's meters cubed, right? Meters cubed is talking about volume. Meters squared is talking about area. So, and again, we have to know how to find those pieces in the formula. Okay, so that's it for this one. I got one more for you. Let's take a look at that one. Okay, so in this problem, it's very similar to other ones that we've seen. They give us a a cone, and from the cone we have to figure out a certain dimension that's missing. And in this case, that dimension is diameter. Remember that from one side of the circle to the other is diameter. And so they're asking us what the diameter is of this cone. Now they give us some other clues or some other measurements or dimensions. They give us the height of the cone, and this time they didn't put it in the middle of the cone, they just put it to one side, very normal thing. So the height is 9 centimeters. And then we have the volume, 150.8 centimeters cubed. Just to repeat, if they don't put the V or they don't say volume is equal to, you have to understand that that is volume just based on the fact that they put centimeters cubed, units cubed, okay? So, okay, what are we gonna do with that? What are we gonna do with that information that they gave us? Well, I put the formula over here to one side because I'm gonna need more space over here. And I just put the pi right here. So the real little funny thing is that the formula doesn't have anything to do with diameter, directly anyway, not directly related to diameter in that sense. Like, it's not like I can solve this and it's going to give me diameter when I'm done solving the formula. In fact, I have to find radius first. I have to find the distance from the center of the circle to the outside edge first, because that's really what the R is. That's what I can actually get to more directly. Once I have the radius, then I can find diameter, because I just got to double it, right? Okay, let's go ahead and get started. So 3.14, radius I just explained is, I'll just go ahead and put parentheses for radius for now. Radius, we don't know. We don't know what the radius is going to be yet, okay? We don't have that in the example here, but we do have height, so I can go ahead and put the height there, another pair of parentheses. Height is 9. All of that will be divided by what? By 3. And this is equal to 150. Oops, not 15, 150.8. Okay? So that's basically how we set up the equation, and now we just got to get to solving it. So I want to try to simplify the numerator. The idea here is to get R all by itself, okay? And to do that, I have to simplify everything else and move it over to the other side of the equal sign where the 150 is. So to do that, I'm going to start by simplifying the numerator, because there's a lot of stuff in the numerator. There's obviously just one number down here. I'm not worried about the denominator yet. But I can multiply pi times 9. Remember that when we multiply, it doesn't matter in which order we multiply it. The whole numerator is multiplied. It's this times this times this. So I can go backwards, forwards, whatever. But anyway, so on the calculator, I'm just going to go pi. I'm going to use a button like I always do. Pi times 9. And I get 28.27433, blah, 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 right? But I'm just going to use 2827, okay? So let's go ahead and put that down. I'm going to I'm going to put the numbers on one side, then R squared. So 2827, or 0.27, I should say. R squared over 3, it's a big long thing, right, is equal to 150.8. So now what I'm going to do now is get rid of the fraction, okay? And I'll go ahead and change colors like I usually do. Drop my marker. Okay, so to get rid of the fraction, the only thing I can really get rid of is the denominator. And it's the easiest way, okay? So that's why I say it like that. So to get rid of the denominator is divided to the numerator. So divided by 3. What's the opposite of divided by 3? So I can undo it, is multiply by 3. And I've done this a few times already, so you guys probably know what I'm doing already, hopefully, right? So the point here means multiplication. The 3 and the 3, they can cancel out, so it just means that they can be reduced dividing a common factor. And that common factor is by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. And there we go. So 1 times 28.27 r squared is 28.27 r squared. Okay, 1 times anything is going to be that other anything. And 1 times 1 is 1. I'll just do it one more time to show that. But 28.27 r squared over 1 is just, or divided by 1 is just 28.27 r squared. It's actually really hard to say, but anyway. So they cancel out, leaving me with just the numerator, okay? I don't like my r's. Man, I'm not having fun with those today. Okay. Anyway, equal to 150.8. But what I did to this side, which was multiply by 3, I have to do that to the other side. So let's just go ahead and put a little pair of parentheses here, and we'll say times 8. I'll break out the calculator just because it's kind of a funky decimal, right? So 150.8 times 8 times 8. Why did I put times 8? Did you guys catch that? Jeez, I didn't catch it. Let's go ahead and fix that before we move forward. It's times 3. I multiplied this side by 3. I got to multiply that side by 3, not 8. Gosh. All right. So I have 150.8 times 8. And that equals, Again, I put 8 here. Darn it, I'm messing up. Sorry about that, guys. 150.8 times 3. I fixed it on the board, but I didn't fix it on the calculator. So anyway, here we go. 150.8 times 3 is equal to 452.4. So let's go ahead and put that down. 452.4. Oops. It's kind of the end of the day, guys. Bear with me. So 452.4. All right, so we're getting closer now. We still have r squared that we need to get r all by itself, but we're whittling this problem down. The next step is to get the r squared and the 28.27 separated. So remember that they're multiplied together, okay? Because the r squared is right up against the 28.27. So to separate them, I'm going to divide. And I divide by dividing. And I want to divide by the number that I'm trying to get rid of. And I'm trying to get rid of the 28.27. So that's what I'm going to divide by. So 28 divided by 28 is 1. 1 r squared is just r squared. Okay. And what I do to one side, I do to the other. I divide the other side also by 28.27, not 8. Darn it. Okay. So 452.4, right? 0.4 divided by 28.27. Okay. Yeah, see, they're trying to get a good angle here. Okay. Is equal to 16.00. I like that. That's a nice, almost pretty darn exact number, right? So 16. Let's just say it's equal to 16. Just kind of approximating, but when it's 0.00, that's pretty good to say it's 16. All right, so now we're at the last step of the equation. And again, we don't want to know what r times r is, which is 16. We want to know what just plain r alone is, right? So to do that, we have to take the square root of both sides. Square root of both sides. Now, I've said this before. This little house thing, it's called a Radicand, and it basically comes built in with a 2. This is the little thing is called the Radicand, like without the 2, just the little house. It's called square root, right? So square root is going to be the opposite of something like r squared. So they cancel out. Just so you know, they never put the 2 there because the house itself, little Radicand, its symbol itself means squared. So but I'll just put the 2 there just so you can see it. And so square root is the opposite of a number like r squared. So they cancel each other out, leaving me with just r. Okay? It's a lot of explanation just to say that to put the house over it and then you're left with the r by itself, right? But over here we really have something to show. So the square root of 16 is 4. All right, and I'll go ahead and do it on the calculator so you can see that real quick. Okay, so on the calculator, on this one in particular, the square root symbol is basically this button that says x squared. I don't know if you guys can see that very well. But I don't want x squared, I want the function that's right above it written in green, and that's my little Radicand, and I have to put that first. So to get the green function, I have to hit the green button. Okay? So I hit the green button, hit that x squared button, but instead of putting x squared, it puts the little square root symbol with an open parentheses. So inside that parentheses, I'll put 16. I could close it. I could close the parentheses. I'll just do it this time, but really it's not necessary in this case. So square root of 16 is equal to 4. Okay? All right. Now, so we have the radius. The radius is 4, but they asked us for diameter. The radius, so we have, let's see here, I can just write this right here. Our radius is 4 centimeters, and my centimeters are going to be hard to read, but anyway, so it's a 4. But okay, so the radius is 4, the diameter is double that, it's going to be 8. Okay? So 8 centimeters. So you can see how it's long, it's a lot of work. It does take time, even with a calculator. It's a lot slower explaining it than actually doing it, I think. Don't get tripped up with the square root, and don't get tripped up with that fraction. I've done it a few times already when we talked about, well, in this same video, and also in pyramids, I talk about that fraction dividing by 3. So let's take a look at a different kind of problem. Okay, you guys, this is a problem I want you guys to try and do before I do it. Basically, we've done similar problems when we did volumes of boxes or rectangular prisms or cylinders, and the pyramid. We did very similar problems. And it's typically the last one of those video series. So anyway, each videos. Anyway, so so basically what I'm saying, these two cones have the same volume. Now your task is to find the distance here. I'm not going to tell you what it's called. This distance of this tall cone that looks like a witch's hat, right? What's this distance called? Can you find it? That's your challenge. Okay, so like I said, these kinds of problems are common, they are typical. How do we start? What should we do first? So, they say that the volumes of the two are equal, but the question is here on this second cone. And when there's a piece of information missing or a measurement missing, typically I need to have the whole volume, or if we're talking about area, I need the whole area or something like that, to be able to use algebra to find that missing piece. Okay, and of course there can only be one missing piece. But what I didn't say earlier is that what is this distance? This is diameter. Remember, from one side of the circle to the other, and we're talking about this circle on the bottom, that's diameter. But the formula, which I have kind of here out of the way, doesn't have diameter. It has radius, right? But that's okay, because we know that radius is half a diameter. If I can find radius, I can find diameter, and vice versa. If I can find diameter, I can find radius. So that's what we need. But to do any of that, I need to use algebra, and to use algebra, I need the volume of this cone. I'm missing information, so I can't find the volume of this one here. But this cone has enough information for me to find the volume. And because it says, but because it says volume is equal in these two cones, if I find the volume here, I'll have enough information to find that diameter. So, all right, so let's get started. I'm going to see if I can't fit the volume of this one. Obviously, I'm going to solve the volume for both of them, but I'm going to use it get the information out of this cone here. So I'm not going to rewrite the formula. It's just right back here, okay? So pi, we know that Greek letter pi is 3.14. And yeah, I'm running a little bit small because it's kind of a small space here. 3.14 times radius. Well, what's my radius? Right? The formula is asking for radius squared. I should give myself a little bit more room. Times height divided by 3. Right? And I'm just going to plug in that information into those parentheses. So what is my radius of this, I'm just going to call it a cylinder, of this cone. The radius is, we're talking about the circle, we're talking about the bottom circle here. And again, they didn't give us radius, they gave us diameter. One side of the circle to across all the way to the other, passing through the center, or basically from one side to the other of the circle. That's diameter. But we know that diameter is 2 times radius, or we could say radius is half of the diameter. So instead of, it's basically this distance, right? So it's going to be 6 inches. Okay. Anyway, so we'll plug that here. 6 squared, radius squared, right? The formula says radius squared, so I have to square that 6, and times the height. What's the height of this cone? Height is 5. And basically that's it right there. You know, I'm going to do one step manually with, you know, by hand, and then the rest will just solve on the calculator. Okay. Not to say that you can't do the whole thing by hand. It just takes more time, right? So, okay. So pi, I'm just going to rewrite that. The thing that I want to do, you know, mentally, or, you know, before we use a calculator, is I'm going to go ahead and square the 6, because we've already talked about this. Order of operations. Well, let's count the operations that we have, right? We have 2 multiplications, right? We have pi times 6 squared times 5, so there's 2 times in there. So we have 2 multiplications, we have an exponent, and we have the fraction, the division. So we have 4 operations. We have 2 multiplications, division, and an exponent. Out of those 4 operations, the exponent comes first, and that's what we have to do first. We always have to do that r squared thing first. So anyway, 6 squared is basically 6 multiplied to itself 2 times, or 6 times 6, and that's equal to 36. Okay, there we go. And like I said, the rest I'm just going to go ahead and plug into the calculator. And I have my calculator right here, my trusty little calculator. Okay. So, trying to get a good angle here. So pi is that little button we've talked about. Let me move up the calculator here. And I'm trying to find an angle where there's no weird glare. Anyway, it's going to be hard. Anyway, so pi times 36 times 5. And again, on this calculator, I can just, you know, put it all together just the way it's written. And then I could just probably say divided by, because the calculator is smart enough to know the order of operations. But I'm not going to do that. I'm just going to, I want to see what the numerator is equal to. The numerator is equal to 565.486677, all that. And I'm going to go ahead and leave that whole decimal and just hit the button divided by, because that basically this number is the numerator. Okay, all this multiplied is right here. So now we're going to do the fraction divided by 3. So I just hit divided by, and I've talked about it before. This means that ANS is the previous answer, so it's that big decimal right there, divided by 3, and I get 188.49. You guys see that? 188.49, and the decimal goes on, but I'm just going to use up to 49. Okay, so let's just go ahead and use 188.49. Okay. And this is all equal to 188.49 inches, right? We're talking about inches cubed. Can we see that in the screen? Yes, yay, it worked. Okay. And that was the volume. Okay. That's the volume of both cones. Now I need this volume so I can work on that one over here. Let's go ahead and set that one up over here. We'll use a different color. Again, I'm not going to rewrite the formula. I'm just going to start with pi as the number 3.14. So, let's see here. I can probably start right here. You don't need to see me. 3.14 times radius squared. Now, okay, in this cone, I don't have radius. Okay, so that's the thing that we're solving for. And so it's just gonna leave it as r squared. Okay, let me make my, it bugs me when one parenthesis is bigger than the other, you know. I like symmetry. Okay, and do we have the height of that tall cylinder? Yeah, we do. It's 20, right? So 20 divided by 3 is equal to, what did we say? we figured that out. It's going to be equal to 188.49. Okay, I'm not going to use unit cubes or units cubed because I'm working it as an equation, right? All right, so this is the equation, and now you can see why we needed the answer, the volume, because I can't solve anything on this cone if I'm missing two things, right? Algebra doesn't work like that. Algebra really wants you to only have one thing missing, one variable in this case, one letter. You know, usually we represent with a letter. I could have represented this with a v, right? So pi times r squared, which we don't know, times 20 divided by 3 is equal to volume, is equal to v. But again, like I said, I can't have a v missing and the r missing. I can only have one for algebra to work. And this is why we had to solve the volume for this one, so we can get that volume here so that we can complete our equation. And this is perfect. We only have one letter missing, one thing missing. Perfect, we can solve for that, okay? All right, so what's the first step? Well, I'm going to simplify this left side of the equal sign. And on this side of the equal sign, I can simplify the numerator a little bit. I can multiply pi times 20. Remember that all of these three terms are multiplied. So it doesn't, and in multiplication, it doesn't matter which one you multiply first. It doesn't matter in which order. And as a result, I can multiply pi times 20. And let's see what that gives us. I'll just type it in first, pi times 20. Okay. Let me back it up a little bit. Pi times 20 is equal to 62.83. Okay. And that's what we'll use, I'm pretty sure. Yeah, 62.83 is good enough. It's accurate enough for our purposes. What was it again? I say it 2 times and I can't remember it. 62.83 r squared times r squared, and I don't need parentheses. You can if you want, but you really don't need them. We know that they're two distinct terms. 62.83 is different from, whoa, I just noticed there's a wasp in here. I hate wasps. Anyway, if I get stung, it's the wasp's fault. All right, so I don't need there's no confusion that they're distinct terms. 62.83 and r squared are different, so we don't need parentheses. Divided by 3, we haven't done that yet, is going to be equal to 188.49. Okay, now this is the point when my numerator is simplified as much as I can. I can't multiply anything else because I don't know what radius is. So at this point, I need to get rid of the fraction. I need to get rid of this denominator. And I always say in algebra, when we're getting rid of the fraction, the only thing that we can really affect or have any change on is going to be the denominator. Okay, that's the only thing we can really change. And that's what we're going to do. To do that, so I have this numerator divided by 3, and that's what I want to get rid of. I want to get rid of that divided by 3. So in algebra, to undo something, to undo an operation, we have to do the opposite. And that opposite operation is going to be multiplied by the thing that we're trying to get rid of, and that's the denominator, the 3. So I'm going to multiply by 3. And we've talked about this. I have to put it in a fraction form, right? Again, you don't need to see me. And so in multiplication of fractions, this is a fraction, 3 over 1 times 62.83 r squared over 3. Those are two fractions. When we're multiplying fractions, in multiplication, we can cross cancel. And that's the whole point of doing this, to get rid of this denominator. These two can be divided by the same factor, by 3. So 3 divided by 3 reduces down to 1. And this 3 divided by 3 also reduces down to 1. And in multiplication of fractions, now this would just be 1 times numerator times numerator, denominator times denominator. 1 times 62.83 r squared is what? 62.83 r squared. 1 times this is going to be this, okay? Multiplying it by 1 doesn't change it anymore. And I've done this before, and I'll do it again. So in the denominator, so it's denominator times denominator, and that's going to be equal to 1. 1 times 1 is 1. But any number divided by 1, 62 blah blah, divided by 1 is 62 point blah blah. Okay? Anything divided by 1 is that anything, is that number. So that's how we get rid of the fraction here, okay? Now, but remember, what you do to one side of the equal sign, you have to do the same to the other side. On this side, I multiplied times 3, and that's what I'm going to do over here with the 188.49. I got to multiply it by 3, and I'm just going to use a calculator. Okay, I'm going to put the equal sign there. All right, now, bear with me here. So 62, no, sorry, I always do this. I'm multiplying this side by 3. 188.49 times 3, okay, let me see if you guys can get that, times 3, right, is equal to 565.47, okay? 565.47. All right, we're almost there. We're getting there, okay? There's just a couple steps more, okay? Couple steps. Now, r squared, well, r is almost alone. R squared is almost alone. Now, to get rid of, I want it alone, right? I'm trying to whittle this thing down so that r is alone on one side of the equal sign. So I have this number, 62.83, multiplied to r squared. To undo that multiplication and get rid of the 62 and pass it over to the other side of the equal sign, remember they're multiplied, so to undo that, I divide. Opposite operation, right? Opposite of multiplication, yes, multiplication is division. So whatever number divided by itself is 1. It cancels out. 1 times r squared is r squared. I've said that many times. Okay? And what you do to one side, we divided this side by 62.83. That's what I got to do over here, divide by 62.83. Okay. So 565.47, okay, divided by, did I hit divided by, yes, okay. I hit divided by 62.83. All right, what do we get? Okay, and hit enter. Holy crap, I got exactly 9. Check that out, that's awesome. I got exactly 9. I'm sorry, I just expected there to be like a decimal. That's a cool, that's pretty nice. I like the way that looks. Okay, so I got 9. All right, cool. And then we just got to do the square root. Okay, the square root of both sides. So this says r times r is equal to 9. What number multiplied to itself is equal to 9, right? But we're just going to show the process of how to do it algebraically. We have to take the square root to undo a number squared. We do what we do to one side, we do to the other side. So like I've said before, these two, the square just and the radicand, this little house, they basically cancel out. They cancel each other out because they're opposites. The way something multiplied cancels out when you divide, you do the opposite operation, they cancel out. So that basically leaves us with the radius, radius equal to, and this is saying the same thing. Square root of 9 is which number multiplied to itself 2 times, because it's a square root, and the square means the little 2, right? Equals 9, and that answer is actually 3. And I'll just do it because I always try to do it to show you guys. I can't figure out where the light is. Okay, so again, to get the square root of something, it's on this calculator, it's this little x squared button. But I don't want x squared. Actually, I'm gonna hit that button, but I'm trying to get that little function that's in green above it. Okay, the square root. To do that, I got to hit the second function, which is the green function. So I'm going to get all now the calculator is going to respond to all those green signs. But I want to get that little square root button, so I'll hit that. It opens up a let me see the light. It opens up a little Radicand. I'm trying to get the light. Sorry, guys. Opens up a little Radicand there, and opens up a parentheses. So I'm just going to put 9 in there. Now I can close the parentheses. You don't need to, but I will this time. What the heck? Let's go ahead and close the parentheses, and it's equal to 3. Okay. So yeah, we're almost done. The radius of this cone is 3. The radius, and remember the radius is the distance from the center to an outside edge, and that's going to be equal to 3 inches. Right? So what would the diameter be? The diameter is double the radius. So it's really not the hardest thing to do once you have the radius. You can find what the diameter is right away. Okay, so that's, again, this is a lot harder to explain, and show every little step like I try to do for you guys. I think it's a lot easier when you understand the problem. You can just start plugging away and getting down to the numbers. I will say that, look how much space it took. Organization is important. I can't emphasize that enough. Organizing things, even if you have maybe different colored pens or pencils or something, sometimes that might help. But anyway, so I can't cover every single problem that exists on cones, but my idea here is to give you guys enough tools and enough examples that you guys can hopefully approach these kinds of problems with a little bit more confidence. The hardest part usually for a lot of people is just getting started. Okay, remember your algebra foo needs to be strong. Okay, you got to be good with your algebra, and yeah, try to always see where to start. That's usually the thing that most people have to work on. If I tell them do this, they usually can solve it. It's that telling that prompt. They got to prompt yourself to get started. So anyway, I'm done. Good luck. Keep practicing. Thanks for watching.